Hello and welcome to this new series of lectures for Class 9 Mathematics. We'll begin this lecture with the topic of lines and angles and build onto this and cover other topics of Class 9 Mathematics for CBSE board. Let us begin this topic, this chapter, by first recalling some basic terms and definitions. We start with lines, and the general notion of a line is that it has no endpoints. That means a line extends indefinitely in both directions. So what we actually draw on a paper or on the whiteboard or blackboard is only a part of the line that has two endpoints. So we call this as a line segment, which has two endpoints, and we denote the line segment by the markings of the endpoints. You can give any alphabet as the notation for each endpoint. So we have an endpoint A and an endpoint B, and we denote this line segment as AB with a line on top. So that's a line segment. So what we draw on the board or on paper is basically a part of the line which has two endpoints. Similarly, if we have only one endpoint and we show that the line extends indefinitely in one direction, we mark the direction with an arrow, and we call this as a ray. So a ray is nothing but a part of a line which has one endpoint and extends indefinitely in the other direction where there is no endpoint. And we mark the ray using the notation AB with an arrow in one direction on top. And similarly, the line itself, when we represent it or denote it, we show it as the two endpoints, or not the endpoints, basically the two directions in which it is ending, with arrows on both sides. Okay, so it's AB with a bidirectional arrow. So that is basically what we call as a line. That's the notion of a line. That means it extends in both directions indefinitely. Okay, so generally what we draw on paper or on the screen is a line segment or a ray. Now that we have some understanding of what lines are, let us now look at angles and when an angle is formed. So an angle is formed when we have two line segments or two rays originating at the same point, or when two lines intersect or meet at one particular point. So in this case, we have a line AB, or a line segment rather, AB, and another line segment AC. They intersect or meet at a common point, which is the point A. So there are two line segments which are meeting at a common point, and an angle X is formed between those two line segments. The meeting point A is called as the vertex of the angle, and the two line segments between which the angle is formed, those line segments are called as the arms of the angle. So we have an arm AB, another arm AC, and there is an angle between those two arms called as the angle X. Of course, we can write this angle X by the common notation as angle CAB. So it is angle CAB. Or we can also write this as angle BAC. Both mean the same thing, and they are both denoting the angle X between these two line segments. So that is the same as angle BAC, which is also identical to the angle X. Okay, all these three mean the same thing. Let me write that clearly. So the angle X. Okay, so X is the angle between the two line segments AB and AC. And again, notice that normally the correct way of writing the line segment is with a line on top, but many a times you will notice that the line on top is missing, and that is understood that it means the line segment AB. Okay, so to reiterate, the angle CAB can also be written as angle BAC, or by the letter X, which denotes the angle. Okay, all these three notations mean the same thing. Now let us look at the different types of angles that can be formed when two lines intersect each other, or when two rays originate from the same point. So there are different types of angles. Let us first look at when the two angles are such that one line is horizontal and the other line is vertical. That means it looks like an L shape here. In this case, we say that the angle between these two lines is 90 degrees. Okay, we call this as a right angle. Let me write that. Okay, so you can write this as angle CAB equals 90 degrees. So what is a right angle? A right angle has a value exactly equal to 90 degrees. So we get a right angle when we have something like an L shape. One line is horizontal and the other line is perpendicular to it, which is basically vertical. We can also have this perpendicular line, not at the end point of the horizontal line, but somewhere in between, meeting it in between the line, horizontal line AB. In which case, again, the angle between them is still 90 degrees, but we notice that it makes 90 degrees on one side and another 90 degrees on the other side. Okay, so when the angle between two lines is 90 degrees, we call this as a right angle. Okay. So for the second case here, we can write that the angle COB is 90 degrees. Similarly, COA is also 90 degrees. So let me write that. Angle COB is 90 degrees. Similarly, angle COA is also equal to 90 degrees. That means the line OC is having an angle of 90 degrees with the line segment OB as well as with the line segment OA. Okay, so we call this as a right angle. Next, we look at the case where the angle between the two line segments AB and AC is less than 90 degrees, in which case we call it as an acute angle. So an acute angle, in this case, we can write this as angle CAB is less than 90 degrees. So it can be anything between 0 degrees and 90 degrees. Okay, the moment it becomes exactly equal to 90 degrees, it becomes a right angle. And from 0 to 90 degrees, we call it as an acute angle. And notice that when we measure the angle is measured in the counterclockwise or anti-clockwise direction. So we go in the anti-clockwise direction from the line segment AB to the line segment AC. That's where the angle is measured. Okay, the next type of angle is when the angle is between the two lines is greater than 90 degrees but less than 180 degrees. So we'll mark these lines segments as say A, B, and C, and the angle between those two lines, which we can denote as CAB, in this case is greater than 90 degrees, and also it should be an angle CAB should also be less than 180 degrees. So we can write this combinedly as a single inequality as the angle CAB, it is lying between 90 degrees and 180 degrees. So angle CAB is greater than 90 degrees but less than 180 degrees. That means it is lying between 90 and 180 degrees, in which case we call this as an obtuse angle. Okay, so we have right angle where the angle is exactly equal to 90 degrees, and acute angle when the angle is less than 90 degrees. Obtuse angle is the angle that lies between 90 degrees and 180 degrees. So again, the angle is measured in the counterclockwise direction between the two lines. So I'll put the arrow like this. So the angle CAB is lying between 90 degrees and 180 degrees. We call it as an obtuse angle. And the next type of angle is called as the reflex angle. Okay, and reflex angle is nothing but the outside angle of an acute angle. So you have an acute angle here. That is the angle between those two lines, which is the inside part here. But the angle that is formed on the outer part of these two lines, that is called as the reflex angle, which is what is seen here. So what you have inside here is the acute angle, and what is on the outer side of this, that's called as the reflex angle. So the reflex angle is going to be between 180 degrees and 360 degrees. It will be greater than 180 degrees and less than 360 degrees. So we write that as, in this case, it's again angle CAB. So CAB is greater than 180 degrees, and it is also less than 360 degrees. CAB is less than 360 degrees. So we can write that combinedly as angle CAB to lie between 180 degrees and 360 degrees. Okay, so we have seen the different types of angles so far here: right angle, acute angle, obtuse angle, and reflex angle. And the last type of angle, not the last type of angle, but the other type of angle here is a straight angle when the angle between the two line segments AB and AC is exactly equal to 180 degrees, as we have over here. So that means the two line segments AB and AC form a straight line themselves. Okay, they form as if they are a straight line, CAB. So the angle here, CAB, is exactly equal to 180 degrees. Angle CAB is equal to 180 degrees, and we call this angle as a straight angle. Okay, so that means the angle that we measure from this line to this line is exactly equal to 180 degrees. And this is something that we should always remember. When we have a straight line, the angle on the straight line is 180 degrees. Okay, so if you go from here to the other part of the line, that's 180 degrees. And if you come back to the other side, that's another 180 degrees. So a complete circle starting from the starting point, coming back to the same starting point, will give us 180 plus 180, a total of 360 degrees. Okay, so a straight angle is when the two lines segments form a straight line together. So they fall in the same straight line. Now let us look at two more properties of angles. One is called as the complementary angles. That is when two angles add up to give a sum of 90 degrees. So when you have two angles whose sum is 90 degrees, we call those angles as complementary angles. And the next definition is what we call as the supplementary angles, in which case the sum of the two angles is equal to 180 degrees. So if you're given two angles, say 45 degrees and another angle 45 degrees, the sum is 90. So we say that these two angles are complementary angles. So, or we can have one angle as 70 degrees and the other as 20 degrees. 70 plus 20 is 90 degrees. So 70 and 20 are complementary angles. Similarly, if we have two angles whose sum is 180 degrees, for example, we have one angle as 100 degrees and the other as 80 degrees, the sum is 180. So we say that the 100 degree and the 80 degrees are supplementary angles. So, or we can have one as 150 degrees and the other as 30 degrees. When you add them, we get the sum of 180 degrees. So we call those two angles as supplementary angles. The next definition with regards to angles is what we call as the adjacent angles. Adjacent means next to each other. Something which is next to each other, we call it as being adjacent to each other. So adjacent angles, as you can see from the figure, the angles are next to each other. So this angle which I marked with the yellow line and this angle which I marked with the pink line, these two angles are next to each other and we call them as adjacent angles. And technically speaking, the property that the angles must satisfy to be adjacent angles is that they should have a common vertex. That means the two angles CAB and DAC, they have a common vertex, the meeting point, which is A. So the two angles have a common vertex. They have a common arm. So one of the line segments is common to both the angles. So this line here, AC, is common to this angle as well as this angle. So this line segment AC is part of this angle CAB and it's also part of this angle DAC. So there is a common arm. And the third condition that must be satisfied is that the two non-common arms must be on different sides of the common arm. So you see that the non-common arm AD and the non-common arm AB are on different sides of the common arm AC. So the non-common arm AD is on the left-hand side of the common arm AC, and the non-common arm AB is on the right-hand side of the common arm AC. So these are the three properties that must be satisfied for two angles to be adjacent angles. Okay, first is they should have a common vertex. Second is they should have a common arm. And the third is the non-common arms must not be on the same side of the common arm. They should be on different sides, one to the left side, the other to the right side. So clearly here, these two angles satisfy all the three properties. So therefore, these two angles are adjacent angles. So let us write that angle DAC and angle CAB are adjacent angles. Okay, how do we know that? Because they have the common arm CA, they have a common vertex A, and the non-common arms are on different sides. One is on the left side and the other is on the right side. Okay, so these angles are called as adjacent angles. CAB and DAC are adjacent angles to each other. The next thing we notice from the adjacent angles is from this figure is the angle between the non-common arms, that is the angle between DA and AB, that is the total angle here DAB, is equal to the sum of the two adjacent angles. So if we mark this particular angle, let me change the color. So this total angle between the two non-common arms, okay, that is equal to the sum of the two adjacent angles. So we can write that as angle DAB, which is nothing but this total angle DAB, is the sum of the two adjacent angles, which is angle DAC plus the angle CAB. So when you have two adjacent angles, the sum of the two adjacent angles will be equal to the angle formed between the two non-common arms. So the non-common arms in this case are AD and AB. So the angle between the two non-common arms is equal to the sum of the two adjacent angles. This is another property that you should remember, and that will be useful in solving problems. Next, we can have a situation where the non-common arms of the adjacent angles form a straight line themselves. If that is the situation, then the two adjacent angles are called as a linear pair of angles. So what is the meaning of a linear pair of angles? If the sum of the two adjacent angles is exactly equal to 180 degrees, that means the two non-common arms form a straight line. So basically, this is what is drawn here, where we have uh, a common arm AC, the non-common arms AB and AD, and we notice that the non-common arms AB and AD form a straight line. That means the angle between the non-common arms is 180 degrees. So that means we'll have it something like this. That total angle is 180 degrees. That means the adjacent angles, which we can denote as, if we can call this angle CAB, and the other adjacent angle DAC. So the total angles DAB is equal to the angle CAB plus the angle DAC. So that gives us a total of 180 degrees. That means we call these two adjacent angles as a linear pair of angles. So let me write it here. Angle CAB plus angle DAC is equal to the total angle between the non-common arms, which is DAB, and that is equal to, in this case, 180 degrees. In this case, we say that CAB and DAC are linear pair of angles. So we say in this case, angle CAB and angle DAC, this is C, are linear pair of angles. So we have this definition for a linear pair of angles. They are nothing but they are adjacent angles whose sum turns out to be exactly 180 degrees. Okay, so the diagram for the linear pair of angles is shown over here. So that's the linear pair of angles, which is two adjacent angles, CAB and DAC, whose sum is equal to 180 degrees. In other words, the two non-common arms of the angles form a straight line. Okay, that is when we call the adjacent angles to be a linear pair of angles. Okay, the next definition for angles comes when we have two lines intersecting and passing through each other. So we have the lines segments here, AB and CD, intersecting or crossing each other at the point O. Then there are four angles that are formed, and we call those four angles as two pairs of vertically opposite angles. So the angle which is formed here is vertically opposite to the angle formed here. So we call those as vertically opposite angles. So this is one angle over here, and the vertically opposite angle to that is on the other side. Okay, so that's vertically opposite angle. So the notation is angle AOD and angle COB are vertically opposite angles. Let me write that, angle AOD. This particular angle here is angle COB, and these are vertically opposite angles. Similarly, we can have the other two vertically opposite angles, which is the angle between these two lines, and the vertically opposite to that is this particular angle, which I marked in pink here. So angle AOC and angle DOB are vertically opposite to each other. So let me write that. That's angle AOC, and the angle over here is angle DOB. So these are vertically opposite angles. That means we have one pair of vertically opposite angles. So AOD and COB forms one pair, and we have the second pair AOC and DOB. So basically, when we have two lines intersecting or crossing each other, two pairs of vertically opposite angles are formed. So the two pairs are AOD and COB is the first pair, AOC and DOB is the second pair. And later we will see and also prove that the vertically opposite angles are equal. That means this angle AOD and the angle COB will be equal. That is AOD equal to COB. And similarly, the angle AOC and angle DOB are also, they both also will be equal. Okay, that means their values will be the same. We will prove that in a later video. But let us first understand what is the meaning of vertically opposite angles and when do we get vertically opposite angles. We get vertically opposite angles when we have two lines intersecting or crossing each other at a point. Then we get two pairs of vertically opposite angles. So that's first pair number one, and that's the pair number two. A pair means two angles, right? So we have two pairs of vertically opposite angles when two lines intersect each other. The next definition that we will see is what is called as parallel lines. And we get parallel lines when two lines do not intersect each other or they do not cross each other at any point. So if you look at these two lines here, this is line number one and line number two. No matter how far we keep extending the line to the right or to the left, similarly, no matter how far we keep extending this bottom line to the right or to the left, these two lines will never meet each other and they will never cross or intersect each other. It's like when you see a railway track, right? The two lines on the railway track, they keep going on and on and on forever. They will never meet each other. We call these as parallel lines, and parallel lines are those lines that do not intersect each other, no matter how far we keep extending them indefinitely in either direction. Okay, and one of the observations that we notice about parallel lines is that if we draw a line, a common perpendicular to the two lines at any point between the two lines, then the length of those common perpendiculars will be the same. So for example, if I draw a line between these two lines like this, which is having a 90 degrees with both the parallel lines, then this length of at this point will be the same as the length at any other point between these two parallel lines. So no matter where we put this length or this perpendicular line, the length of each of these perpendicular lines will be the same. And that length is equal to the distance between the two lines. So line number one and line number two, they have a certain distance between them, and if they are parallel lines, the distance measured at any point will be the same. Okay, so if you draw a common perpendicular to both the lines, irrespective of where we draw that common perpendicular, whether we draw it here or here or here, the length of each of these common perpendiculars will remain the same, and it will be equal to the distance between the two parallel lines. And we have non-parallel lines, or lines that will intersect each other or cross each other. That means they are not parallel lines. So for example, let me just draw some line here. I'm just going to make it like this. And a second line, which I will start from here. And if you notice now, at the moment, they are not intersecting. But if I keep extending this line further and further and further, at some point, you see that the two lines are crossing each other. So we get a point of intersection over here. So that means these are intersecting lines. That means the lines are not parallel to each other. And if we had to measure the distance between the two lines, the distance will not be the same at all points. So for example, the distance between the two lines at this point, let me change the color. So the distance between the two lines here is different compared to the distance here, compared to the distance here, compared to the distance here, and so on. And at the point where they meet, the distance is 0. So intersecting lines cross each other at some point if we extend them in one direction or the other. Okay, so intersecting lines basically are non-parallel lines. So in this video, we have seen some basic definitions and notations with regards to lines and angles. In the next video, we will start with some properties and theorems and see how we can use these ideas to understand how to calculate different angles between different lines when they are intersecting each other, or when one line is standing on top of another. So we will see how to use these properties and calculate various angles and see also the properties of different angles. Okay, we will continue that in the next video. So please like and subscribe to my channel, and if you want to learn any specific topics, please do write what topic you are interested in the comment section, and I will try to make a video on that topic as soon as I can. Thank you.